So in this problem, we need to verify that at least two of the three constants, A, B, and C, these three are going to be equal if we have three lines whose equations are given to us. These three lines are concurrent. Okay, let us begin. So here we have three lines. So let's say we have the line 1 with the equation ax plus a squared y plus 1 equals to 0. Then we have the line L2 with equation bx plus b squared y plus 1 equals to 0. And then we have the line L3 with the equation cx plus c squared y plus 1 equals to 0. Now we have to show that there are three constants here, a, b, and c. Of these three constants, at least two of them has to be equal, provided that these three lines L1, L2, and L3 are concurrent. So concurrent means they are going to have a common intersection point. Now we know the condition for concurrency. So here we are going to take the 3 by 3 determinant and we're going to equate it to 0. So in the first row R1, we're going to consider the coefficients of x and y and the constant term, and those are going to be the elements of row number 1. So we have a squared, and 1. Then in the second row, we are going to consider the coefficients of x, y, and the constant term of the second line L2. So we have b squared, and 1. Similarly, in the last row R3, we're going to consider the coefficient of x, y, and the constant term of line 3. So we have c squared, and 1. Now what we'll do, we're going to expand it along the first row. So we have a multiplied to, so b squared times 1, that's going to be b squared, minus c squared times 1, so that's going to be c squared. Then we have negative, then we're going to consider this element a squared. A squared is going to get multiplied to b times 1, so that's b, minus c times 1, so that's going to be c, added to the element in the first row, third column, so that's 1. 1 is going to get multiplied to, so we're b times c squared, so that makes it b squared, bc squared, minus c times b squared, so that's going to be cb squared. This is going to be equals to 0. Fine. Now let's simplify. So b squared minus c squared, that's the difference of two squares. We can factorize it to get the product of b minus c and b plus c, minus a squared times b minus c. Let's keep it as it is. Now from this term, we're going to take negative bc as the common factor, such that this gets multiplied to b minus c, so that's equals to 0. Now from each of the terms, if we take b minus c as the common factor, so b minus c gets multiplied to a times b plus c, so that's simply ab plus ac, minus, so from this term we have taken b minus c as the common factor, so negative a squared stays behind, and then from the third term we have negative bc staying, so this is going to be equals to 0. Now we have product of two numbers that are equals to 0, so that means that b minus c equals to 0, or we have ab plus ac minus a squared minus bc equals to 0. However, we do not have to worry about the second equation. B minus c equals to 0 directly gives us b equals to c. So we were able to show that of the three constants a, b, and c, the b and c are going to be equal to each other, hence proved.